Scale of 1 is to 200. Okay, and in the corner. And what I'm doing then is the spectator from corner A is at a 60-degree angle by 80 millimeters out. We've drawn the furthest point on the left to the eye of the spectator. We're going to take the furthest point on the left, sorry, on the right to the eye of the spectator. We're going to bisect that angle. Giving us our CLV, and then the picture plane is going to be 90 degrees to the CLV at corner A. So this is our picture plane. Get our vanishing points. We go parallel to the two main bodies of the, or planes of the object. So this is parallel to this one, and this is parallel to that side. So this is our VPL in our plan view, and VPR. Now, at this stage then we untape the page. Set up our T-square to that picture plane, and we retape it up. And underneath the spectator here, we're going to draw our horizon line. And instead of 70 millimeters below this, we're going to go 35 millimeters below. And we'll draw our ground line. From corner A, I'm going to draw in our reference height line. Now, our reference height line is the true height when the picture plane is touching up against that corner. So any heights involved in this question are half of 28 is 14. Plus 32. So 28 and 32 is 60. Half of 60 would be 30. And plus another 5. So 50, 60, 70. So I have 3 heights involved in the question, and my 3 heights, if they were real heights, will be marked off there. Okay, and the last thing I suppose actually I forgot to do was bring down my VPL, VPR. To both And as part of the setup as well, we're going to put in our ground lines. So where my ground would sit would be here, disappear to the right hand side. Again, that's that plane disappearing off to the right. This plane here disappearing off to the left would go from the ground at corner A all the way to VPL. That's our ground heights. Okay. And for the setup, that's as far as we need to get for tomorrow. Okay. Yeah.
What is it 3.5?
What's half of 3.5? So
1.75.
So you're saying 3.5 meters. Right, what's that in millimeters? What is it? Said multiply by 1,000. From meters into millimeters. And then divide by 200 then. There you go. It's 7 meters, but it's to a scale. We've changed the scale to fit on our A3 page. In the exam, the real exam, big exam, you will be getting your A2 paper, which is double the size. So the scale of 1:100 will fit. And usually what we're used to is sticking this plan view maybe into the corner. For this one, we had to move it out a little bit just to give us a little bit more room towards this corner of our page. All these small things matter to relate to when we're doing exam time, okay? So, to add the scale to the question, okay, the heights of these are no longer applicable. So heights that we have were 5, 16 and 14 millimeters. Isn't that correct? So those three heights, okay, all added up, are then added onto our reference height line. So we come up by 14 millimeters, another 16 millimeters, and then another 5 millimeters. And there are three heights that are involved at some stage in this coffee dock, horse box, whatever you want to call it. Okay. So we also have our VPL and our VPR, and we know that any lines going in this direction here are all associated with VPR, and any lines going this direction here are all associated with VPL. We can now start to form our perspective view, and what I would advise here is maybe taking our 3D graphic here, okay, and labeling different points or lines on that 3D graphic. So for example, this here might be line 1 or edge 1, this might be edge 2, this might be edge 3. So by labeling the 3D graphic, we can then transfer those labels to our two-dimensional one. So therefore this is going to be edge 1, edge 2, edge 3, we can do edge 4, edge 5 and edge 6, and these are all vertical edges I'm referring to, okay? You can see all that, okay. So, corner A, again, this is something I noted at the start of the question. Corner A is not actually touching the object, okay? So that's something to note. When you draw your perspective, it should look something like this graphic here, where it's stepped away from the corner. So what we're going to do then is we're going to take the height that is used on edge 1 to 3 and surface maybe 2. Alright, because we want to we want to start forming the outline of it to maybe then fill in the inner detail. There's just a line here that I forgot to do in heavy, so I wanted to draw that in. Okay, so from corner A, I'm going to do edge, we call it edge 2-6. Okay, and then I'll do the or the surface or the plane containing 1-3. So the height for 1-3, again looking at our sheet here, the height for 1-3, this is where 1 is, this is where 3 is, the height involved there is only one height, and it's this point here, so therefore it's the full height of the object. Okay, so therefore it's going to be this full height here, and that line I've already drawn. So now what I need to do is I need to find the location of edge 1, the vertical edge 1. So how do I do that? Well, what I do is I get corner 1, vertical edge 1, and I bring it to the eye of the spectator. Wherever that hits the picture plane, I then bring that straight down. Wherever it hits the ground, that is edge 1. If I bring edge 3 down, same thing. So bring it to the eye of the spectator. Where it hits the picture plane, bring it straight down. And that will be edge 3. So this is the surface 1-3. That's what it looks like. Do we understand that? We all get that there, yeah? And if we wanted to, I could colour it in. So the blue surface there that I'm referring to is this blue surface here. The next thing then would be the green surface, maybe 1-2. Okay. Or the surface containing 2-6. So what I'll do is, again the same thing, I've got this plane, the ground line running along here from edge corner A to 6. As it goes that way it's going to disappear, so it's going to disappear to the VPR. So what I need to do is find the location of where 2 hits the eye of the spectator and where 6 hits the eye of the spectator to give me that surface. Again, the heights involved of surface 2-6 are the following. That height there and there. This is 2 and that's 6 according to mine. So that height at the top, that's what I'm going to solve next. So I brought 2 to the eye of the spectator. Where it hits the picture plane, I'm going to bring it straight down. That's where 2 would end up being, and this is where 6 would end up being. And they're both at this height. Okay, so along the ground we have 6 would be here. That's the overall height of 6. And this is where 2 would be. So surface 2-6. The front vertical surface where the opening is, where you get your coffee from the coffee cup, looks like this, with perspective applied. One and 2 can be connected, and that would be my green surface 1-2 that I have referenced in the plan view up above. So there's the green edge, green surface. Is that starting to make sense? Okay. Now, the next thing then that we're going to do is we're going to do the opening here, or maybe the bar is along there, or a countertop that we would have along here. It's at a height of 14 millimeters along the surface or plane 2-6. So at this height, if I bring that height of 14 millimeters to the VPR, that's the height that's involved along this plane here. Okay? So then at this stage, if I bring VPL involved, so I've got 0.6 here, see the height, 14 meters at edge, or vertical edge 6. If I bring that, my VPL through that point, I can find out along this line going this way, where that, how far that bar sticks out. And the way by doing that is taking this edge here, bring it to the eye of the spectator, it hits the picture plane, we bring it straight down, and that identifies to me how far the bar is sticking out. The bar is sticking out that far there. So then therefore, I can go through VPO then, to get the front edge of the bar. I can get this location here, so this is the front edge of the bar here, disappearing from VPO all the way back across. I can go through edge 2 on VPL, and that will tell me how far it's sticking out this way. So this here is the countertop or bar area where you'd rest your coffee or put in your sugar or your milk or your whatever. Okay. The opening of the coffee dock then is here, this location, so that's your window. I'm going to call this vertical edge 7. So on the green surface there, 2,6, we need to find the vertical edge 7. So how do we do that? We bring 7 to the eye of the spectator, where it hits the picture plane. We bring it straight down. And again, that's going to be there like that. Okay. Now, more or less, the last thing involved here is to find the sloping surface B. Yeah. B and sloping surface C. So surface B is sloped. You can see me writing that. You can at 25 degrees. Okay, so it's sloped at 25 degrees. So is edge C. Now, can everybody just take a pause for a second? Look up here and tell me. Listen to my question carefully, please, so that we're all understanding. Can everybody see sloping surface B? You can see it here on the graphic, and you can see it in the image there as well. Okay? So, sloping surface B, B, and B. The slope, this surface here, is the slope sloping towards or in the direction of vanishing point L or vanishing point R. The slope is going towards or in the direction of, the slope is going in the direction of VPL or VPR. Hands up. Back to me.
VPR?
VPR. So you think the slope is going that way. It's sloped at 25 degrees going that way.
Well, I'll say, not B.
So there's a slope of 30 degrees. Is that the slope? No. Is that the slope? So this surface here, okay, is it sloping that way? Or is it? So here's my slope. Look, I've roughly it's 30 degrees, not 25 degrees. Or is it sloping?
Oh, that would be it.
It's sloping that way. Yeah? Does everyone understand that? Yeah? Is it sloping that way?
Yeah.
Or is it sloping that way? That's VPR. And that's a slope towards VPL. Hands up who thinks it's sloping towards VPR. Hands up who thinks it's sloping towards VPL. Good. So we understand what I'm talking about there, yes? Yeah. There's my slope. This is a 30-degree slope. And we know that the roof is sloping up that way, isn't it? Right. So that means it's engaging with VPL. We've all identified that. Okay? So what we need to do is we need to take a 25-degree slope and engage it with VPL. So what I'm going to do is I'm going to take this VPL line, I'm going to take my protractor, which I need to borrow something. I lent mine out, never got it back, so I just need to find one. Nope, I have one there. So watch this. Now you can do this in either direction, but it's important that you engage it with the correct vanishing point. I can't do this to VPR because it's not sloping in that direction. Do you all understand that? So what I'll do here is I'll take VPL, alright, and from this point, like I can show you a 30-degree angle there, sloping in the direction of VPL. You understand that it's sloping up the way here. Yeah? What I'm going to do is I'm going to take that angle and I'm either going to flatten it down this way. I'm representing the 25-degree angle, by the way, with my 30-degree sector, just because they're very close to each other. Or I can take it and I can flatten it down that way. Either one works, it doesn't matter, as long as you're engaging with the correct vanishing point line. Do you all understand that? So, I'm going to take my VPL, I'm going to go this way. I'm going to take my 25 degrees from the spectator's eye. There's 25 degrees. I'm going to do this in an orange colour just so you can see it and it stands out. And I'm taking a slope of 25 degrees. Here is a 25-degree slope. Do we all see that? Orange line, 25-degree slope. And all I now need to do is then take 90 degrees. Where's my other set? It's going on here. I need to take a 90-degree angle from VPL to interact with that slope. So there's a 90-degree line. Very important that it's 90 degrees. It has to be 90 degrees here. Because if you look at my set square, look at that's a slope. See my set square? That's a 30-degree slope. Very close to 25. Imagine it's resting that way. And I fold it down. I want to be engaging this slope, 90 degrees. And what we're trying to do is we're trying to find this height here, essentially. So if I then take my blue here, just to highlight this, this is then what we take. That measurement. We're going to take that measurement with my compass, the height. Okay. See that H? Yeah? I'm taking that. Now, can you tell me here, if I look at the perspective, is the slope going uphill or is it going downhill? From edge, see edge 26, which is along here. Is it going uphill as it travels that way, or is it going downhill as it travels that way? So as it goes this way, is it going uphill or is it going downhill? It's going uphill, isn't it? So therefore the height that I'm just after taking here will then be applied above VPL there. I'll just show you how I've identified that again. So that H is then transferred down here. And that is what we call AVP, auxiliary vanishing point. And what I will then do is I will take edge 2 and I'll bring it to AVP. I'll bring edge 6 to AVP, and that is going to be where my roof, this roof surface B, is sloping towards. Okay. I'll call this point 8, and point 9. See points 8 and 9? How do I find point 8 and 9 along these two sloping lines? What do we have to do? Same as we did before. We bring them to the eye of the spectator. I'll do this in blue so you can see it in blue a little bit. Bring it to the eye of the spectator. Where it hits the picture plane, we bring that straight down. And wherever it crosses that sloping line, that is point number 8. We do the same thing with point number 9. And you have the majority of it solved.
Where do I go through?
Just get your lunch and meet me there at the time. It's okay.
Do we go to the projection room now or at night?
The water cream, yeah. Get your lunch first, bring it with you.